potential from electric field. Suppose that as a function of x, y, and z, an electric field has the following components. So Ex is given is equal 6x squared y, Ey, Ez, and so on, where the E is measured in volt per meter and distance is measured in meter. Find the electric potential difference between the origin and the point where x is equal 4.8, y is equal to 3.2, z is equal to 0. Now this problem basically can be solved in two ways. The first way that I would recommend is basically would be in this way. So V is equal negative EdR, right? So now our E vector is equal to the EXI vector plus EY J vector and EZ K vector. What about dr? Dr itself is equal to the dx I vector plus dy j vector plus d z k vector. Okay, so let's put everything there. So that means v is equal minus integral of ex is equal to what? Ex is equal to the, open the bracket, 6x squared y. This will be the I vector, right? So let me put it I vector, and then ex, so the ey j vector is equal to what? Plus 2x power of 3 plus 2y. This is our j vector, so that one has to be, and then plus 0, right, which is our z vector, multiplied to the dr. Dr is equal to what? Dr is equal to the dx I vector plus dy j vector, and the last one is dzk vector is 0, so I don't need to put it. So now we know that I times I vector times I gives you 1, so is 1, and I j gives you 0. Okay, so that means here what we will get? We will get 6x squared y, correct, and dx, correct, and then plus dx cube plus 2y, so let me just 1 multiplied to dy. Okay, so then we can say that 6x squared y dx minus 2x power 3 plus 2y. Okay, now what are the limits now? Now we know that we need to find the electric potential difference between original point and the point where 4.8, 3.2 and 0. So that means for the x1 what we have limits, so from 0, from origin to 4.8. okay, what about the dy? Okay, what about the for the y? We have 0 and 3.2. So that's it. I think if you the rest of thing will be just the math. So once you calculate, you plug numbers, you get the answer. Now what about the second way of solving? The second way of solving is basically you solve it separately, each one. Okay, where you have a general formula which is dv. Dv means at any point p minus p0 is equal integral of the e dx, okay, for the x and you do the same for the VP. This is x, is x VPy minus V0y. This is x, so in this minus E dy. And finally, what you have to do is basically V is equal Vx plus Vy plus Vz. That's it.